This problem from two-dimensional motion of particle dynamics in Cartesian coordinate, and it is also from Calcutta University paper 2022 semester 4 and CC10, right? And the problem is a particle describes a path with an acceleration mu into y to the power minus 3, which is always parallel to the axis of y. Okay, the force is parallel to axis of y and directed towards the axis of x. The force is always directed towards the axis of x. If the particle projected from a point A, 0a, whose coordinate is 0a, with a velocity root mu by a parallel to x-axis, then show that path describe a circle. Okay, we draw a rough sketch here to show all the force and all the condition. Let this is x-axis and this is y-axis, and it is the point A, initial point, coordinate is 0a, from where the particle project, and the initial velocity is root mu by a parallel to x-axis. So this is the initial velocity parallel to x-axis, and initial velocity is root mu by a. Okay, and let the curve of the particle be like this. If we draw this type of curve, okay, we consider any point P on the curve whose coordinate is xy, and here it is given that the acceleration parallel to axis of x, this is parallel to axis of y. So this is the only force or only acceleration. We name this force is F, and this is given by mu into y to the power minus 3. So this is mu by y cube, and it is directed towards the x-axis. So it is directed towards the x-axis, and there will be no force parallel to x-axis. So if we name this force is Fy and this is Fx, so this is 0. Okay, now we write the equation of motion of the particle at P of unit mass along x-axis and y-axis. Okay, we write first the equation of motion of the particle parallel to x and y axis. The first equation is d2x by dt2. This is equal to fx. This is the force or acceleration parallel to x-axis, which is given by 0. And we name this equation is equal to 1, and the second equation, that is the equation of motion parallel to y-axis, is given by d2y by dt2. This is equal to minus fy, and this is minus mu by y cube. Name this is 2, and here negative sign taken since Fy towards x-axis. Okay, since the force is along x-axis, that is decreasing direction of y. Now one gives, we integrate number 1 equation, we get dx dt, this is equal to C1 as an integrating constant, and initially at A, x equal to 0, y equal to 0, and dy dt, this is equal to 0, dx dt, this is equal to root mu by a. because here it is given that there is only velocity parallel to x-axis, not any velocity other direction. So dy dt equal to 0 and dx dt equal to 0. We use this initial condition here and get C1, this is equal to root mu by a, and we write the equation as dx by dt, this is equal to root mu by a. This is number 3 by putting the value of C1. And now from equation number 2, that is 2 imply, we multiply both sides of equation number 2 by 2 into dy dt. So we get 2 into dy dt into d2y by dt2. This is equal to minus mu into y cube 2 here dy dt. And this relation gives dt of dy dt whole square, and this is minus 2 mu by y cube dy dt. Now integrating this relation, we get dy dt whole square. This is equal to 2 mu into y to the power minus 3 plus 1 by minus 3 plus 1. Here another minus 1 is present, and this is C2. This is another integrating constant, this is C2. Okay, so we get dy dt whole square. This is equal to minus minus cancel out, 2 to cancel out because this is minus 2. So we get mu by y square plus C2. Now again we use initial condition. We get dy dt equal to 0 at sorry, this is y equal to a. This is not 0 because this is 0a. So we get C2, this is equal to minus mu by a square, and putting this value of C2, we get dy dt whole square. This is equal to mu by y square minus mu by a square, that is mu into 1 by y square minus 1 by a square. And from this relation we get dy dt. This is root mu by a into a square minus y square by y, and this is relation number 4. Now if we divide relation number 4 by relation number 3, then we get dy dx, because 4 by 3, this is dy dx, and the right side is this cancel out, and this is sorry, this is root a minus y square by y. Okay, and this gives y into dy by root a square minus y square. This is equal to dx. Now integrating this, we get another constant. This is let k, and put a square minus y square, this is equal to z square. So we get minus 2y dy, this is equal to 2z dz, that is y dy, this is equal to minus z dz. And putting this value, we get integration minus z dz by z, and this is x plus k, right? And integrating, we get minus z, this is equal to x plus k, and squaring both sides, we get z square, this is equal to x plus k whole square. And by putting the value of z from this relation, we get this relation becomes this given by a square minus y square, this is equal to x plus k whole square, and this is x plus a whole square plus y square, this is equal to a square. Okay. Now we use again the initial condition a at x equal to 0, y equal to a, that is we put x equal to 0 and y equal to a, then we get k, this is equal to a. So we get this equation becomes x plus a whole square plus y square, this is equal to a square, and this must be, this is a circle of radius a and center is at minus a comma 0. Okay, so we prove here the path describe a circle, and we also write here the radius of the circle is a and the center of the circle is minus a 0. Okay, this is the complete solution of our given problem, and this is very important but very easy problem. Okay, thank you for watching.